Use grouping to factor this cubic function and state all zeros. Now they probably should have said all real and complex zeros. Because just saying state zeros, like normally the assumption is only real there. So I mean, normally they would say real and complex. Okay, so first things first, looking at this, they didn't give us any of the zeros. How should we start this one? Pretend you didn't see this. Okay. How did I tell you last class? How would you find the roots? So pretend you didn't see the first part. Last class, oh, I know it was so long ago. But how did we find the roots last class? Yeah. Um, uh, that we would have to be given this out to. Right, we did end up using a calculator. Remember, we plugged this into the calculator and we used that on the or what we did was we used that rational root test. Remember the P and the Q? So if we were right, if we were in school, we'd have to use the rational root test, the P and the Q, to guess at some of these roots. Or if we're out of class, we just use our calculator, right, to find where it touches the x-axis. Now, sometimes our polynomials are super, super nice because sometimes they easily factor by grouping. So anytime you're given a polynomial of uh, even numbered terms, so this has 4 terms, we can first try to factor by grouping them instead of using the P and Q um, or instead of using our calculator. So here, factoring by grouping tells me to group the first two, group the last two. Does anyone remember from last year what you do now? Yeah, you take right? I love the grouping. Again, everything like about math that is great is all of the eloquent parts. And factoring by grouping is so great because everything ends up working out. Here, you pull the GCF out of both of these groups. So the GCF in the first two terms is an x squared. I pull it out. When I say I pull it out, I mean divide it out. Do I know why I say oh, that's just how I always think about it in my head. Okay. Really mean is divide an x out of both terms. So here x cubed divided by x squared leaves me with an x. Negative 5x squared divided by x squared leaves me with a negative 5. And then here I divide the GCF of 9 out of both terms. So I'm dividing 9 out and putting it in front. That's how you deal with GCFs. And I'm left with an x minus 5. Now, what tells me factoring by grouping will work on this problem? What is the indicator? Right, yes. Factoring by grouping, yes. Factoring by grouping only works on problems where once we pull the GCFs out, the insides are the same. And the reason factoring by grouping works in this case is because technically the x minus 5 and the x minus 5 are GCF of these two terms. So now what you're actually doing is you're pulling another GCF out of both of these terms. There's technically only two terms here. So we're pulling x minus 5 out of both terms. which when I say I'm pulling x minus 5 out, what I really mean is I'm dividing an x minus 5 out. So if I divide an x minus 5 out, what am I left with on the first term? Yes, yes, Ruby, yes. So here, when I divide out the x minus 5, I'm left with an x squared. And on the second term, when I divide out an x minus 5, I'm left with a 9. So yes, as Ruby stated, this right here is an example of what we did at the beginning of class, right? This x squared plus 9, and I'm going to do it over to the side just because I want you to see exactly what's happening. How would I take this and find my zeros? What do you do to something? What do you do to a factor to then find the zero of that or the root of that factor? Yeah, set it equal to 0 and solve for x. So that means I'm going to subtract the 9 over, but then the x is squared, so I need to square root both sides. So the square root of x squared is x. The square root of 9 is 3. So what I'm doing is I'm going to pull out a square root of 9, and I get plus or minus 3. However, I still haven't dealt with the negative inside of that square root. Instead, because I pulled that 9 out already, I'm left with the square root of negative 1. Yes, yes, exactly. And the square root of negative 1 is replaced by an I. So here, my full set of zeros are a positive 5 and a plus or minus 3i. Anytime you have what you guys were referring to as sum of squares, it is just the plus or minus square root of that number with an I tacked on. So if you had like x squared plus 16, what would our roots be for this problem? Oh boy, we're about time. Exactly, plus or minus 4i. Wonderful. Any last